Today we're going to start talking about the trig function graphs. And I wish I could have given you a copy of this, and I am going to post it just in case for those of you who might want to copy that down. But I do for sure want you to have out your unit circle so you can see how I'm getting these values. And I want you to see the shape of what the sine curve looks like. And I'm going to be writing down some information. You can always just make a sketch of this. You don't have to be as detailed as I am here because you probably don't have the graph paper and you don't want to draw out or write out all those things. But using your unit circle, we're going to start with 0. And so if you were to look up sine of 0, so on your unit circle you can see, remember it's the y coordinate, sine of 0 is 0. So we would plot the point 0, 0. Then if you look at sine of pi over 6, so on your unit circle, if you check that, sine of pi over 6 is 1/2. So I'm going to plot a point at approximately 1/2. Sine of pi over 4, if you look at your unit circle, you'll see that it's the square root of 2 over 2. Well, I wrote down that it's approximately 0.71, so I'm going to kind of plot where that would go. Sine of pi over 3 is square root of 3 over 2, which is approximately 0.87. So it's going to be about here. Sine of pi over 2 is the top of the unit circle, so that's 1. Sine of 2 pi over 3, again, using your unit circle, you'll see that it's the square root of 3 over 2. Sine of 3 pi over 4 is the square root of 2 over 2, so about 0.71. And sine of 5 pi over 6 is 1/2. Sine of pi is 0. As you move on, and you might already start to see, if you can kind of see this curved pattern, sine of 7 pi over 6, now we have moved into quadrant 3 when you look at sine of 7 pi over 6. So now sine is negative. Notice there's a 6 on the bottom, so it's still a half, but it's going to be negative a half. And then next we're going to have negative root 2 over 2. So we're going to plot about where that goes. Then we're going to have negative root 3 over 2, which is about negative 0.87. So I'll kind of put that where it goes. And then at the bottom of the circle, the sine value is negative 1. And then you can kind of see, I'm just going to you can see this now, this pattern. Okay, now, if we had rotated in the other direction, then it would have, so for example, sine of negative pi over 6. Negative pi over 6, remember when you are drawing that angle, that just means that you are rotating this direction, pi over 6. So it's still going to be a half because it's, but it's in quadrant 4. But there's a 6 on the bottom, so sine of that is going to be a half. So we're going to have negative 0.5. And I'm going to pause this video and then just kind of draw in the rest of it so you don't have to sit here and listen to it all. Okay, so once you plot all those points, you can, when you connect them in a smooth curve, now this would keep going. We're choosing to stop there, but it would keep going. So this type of function is called a periodic function, or sometimes referred to as an oscillating function. And that just means that it's or cyclical function because there's a cycle and then it repeats. So notice that from negative 2 pi to 0, that's one cycle. It goes up to its maximum, it comes down to its minimum, and comes back to the x-axis. Then notice from 0 to 2 pi, it goes up to its maximum and down to its minimum and back to its starting point. So we actually would say that the period is 2 pi because that's how long it takes to make one complete rotation. Now notice this is going around it's a different view. It's like the unit circle because we were getting this from 0 to 2 pi as one trip around the unit circle. So so it's kind of that idea, but here we're graphing this as as real numbers in the real numbers system. So the period of this is 2 pi. Next, we're going to look at the cosine curve, and you will notice some things about that. Actually, but before I do that, let's mention the domain. Notice the domain, I mean, I could put any value in for x, so the domain is actually all real numbers, or we could say from negative infinity to infinity. The range, however, goes from -1 to 1. So I could either write it like this, or I could write it like this. But that would be the range for my sine function. So this is all important information for us that we need to know. All right, moving to the cosine curve. We're going to start it off the same way. If you use your unit circle, cosine of 0, you'll notice, if you look at that ordered pair, remember the cosine function is the x-coordinate, so cosine of 0 is 1. So we would plot that. Cosine of pi over 6, and let me grab these numbers here. So cosine of pi over 6 is the other, I remember sine of pi over 6 is half, so cosine of pi over 6 has to be the other one, square root of 3 over 2, which is 0.87. Pi over 4, cosine of pi over 4 is root 2 over 2, so that is going to be the 0.71. And pi over 3 is a half. Cosine of pi over 2, so that would be up at the top of the unit circle, and the x-coordinate would be 0. And then for 2 pi over 3, we are back to the half, except it's negative. And for 3 pi over 4, 5 pi over 6. And at pi, you're at the left side of the unit circle, so the x-coordinate is -1. So you kind of see this curve here. Then we would kind of keep going, and I'm just going to kind of fill in using a pattern here. Okay, I'm going to go ahead and pause this and fill in the rest of the dots. All right, so I filled all in, I plotted all the points and connected it in a smooth curve. Again, please keep in mind this would keep going because it is also an oscillating function. Now, these types of functions are often called sinusoidal functions. And a sinusoidal function doesn't have to be sine. It can be cosine. So sine and cosine are considered sinusoidal functions. So in case you hear that terminology, don't think that it has to be a sine function. It could also be a cosine function. So let's talk about the period. So if you look at the period here, and I'm going to start at 0 because that's a good place to start. And notice that when does it get back to when does it do one complete rotation? Well, it's at its max here, and it's going to go down to the minimum and then come back up. So you'll notice that the period is still 2 pi. The domain, again, we can plug in anything, so still all real numbers or negative infinity to infinity in interval notation. And the range, highest is 1 and the lowest is -1. Or in interval notation, from -1 to 1. Okay, so that is the cosine function. Now I like to think of where it is at 0, and I think of how sine starts at 0, 0 at the origin. It passes through the origin. But cosine does not pass through the origin. It starts kind of at the max, at the maximum value. So just to kind of use that as a reference point. What I want to show you next is how cosine gets its name. So here it is. So notice that if I take my sine function and my cosine function and put them on the same graph, it kind of looks like that cool, like a DNA strand. But if I take my cosine function and I shift it, I'm going to take, watch what happens to this 0, 1 point when I shift it over pi over 2, which is the same as 90 degrees. So if I shift it over, to pi over 2, notice that they match up. They would be perfect if I had drawn my graphs perfect. So shifting it over to pi over 2 means they match up. Pi over 2 is the same as 90 degrees. So one of the things, and you may or may not have noticed this, is if you have, and you can try this on your calculator, if you look at, I'll do some with the exact values. So say sine of pi over 6 is a half. You're probably not going to notice it with radians, but you would with degrees. So if you had sine of 30 degrees, which is the same as pi over 6, you get a half. And cosine of 60 degrees, you get a half. Sine of 60 degrees is root 3 over 2. Cosine of 30 degrees is root 3 over 2. Try sine of 40 degrees. And you might have to grab a calculator to do that. So if we try sine of 40 degrees, this is not one of the special angles, so we don't get a value. Do you know, but so we get approximately, yeah, get my pen back, approximately 0.64. And do you know what I would compare that to? I don't know if you can take a guess or not. Cosine of 50 degrees, same thing. So what this is illustrating is, notice my angles, 30 plus 60, 60 plus 30, 40 plus 50. It's the reason why sine 45 degrees and cosine 45 degrees are the same. It's the reason why if I shift my graph 90 degrees, they match up. Remember, when two angles add up to 90 degrees, what do we call them? Complementary angles. Add to 90 degrees. That actually is where cosine gets its name, because it's complementary to sine. And it illustrates this idea here, as well as the relationship between those angles. So that's good to know. So to get our tangent graph, I want to talk about, or remind you that tangent x we can think of as sine x over cosine x. And we're not going to graph, I'm going to maybe plot a few points, but I'm just going to use basically the quadrantal angles, and I'll probably use the pi over 4 angle as well. If we take 0 degree, or at 0, remember that sine, if we wanted to do tangent of 0, because it's not on our unit circle, but we do sine of 0 over cosine of 0. And sine of 0 is 0, cosine of 0 is 1. We're allowed to do 0 over 1. We get 0. So we're going to have this right here. But at pi over 2, if you were to take tangent of pi over 2, you get sine of pi over 2 over cosine of pi over 2. And when you do that, you get 1 over 0. And we can't have that, it's undefined. Well, on a graph, when something is undefined, do you remember what we do there? It's an asymptote. So at pi over 2, we're going to have an asymptote, and that's going to happen at all the odd multiples of pi over 2. So at negative pi over 2, we're going to have an asymptote. At 3 pi over 2, we're going to have an asymptote. And at negative 3 pi over 2. So it's always a good idea to draw those in. Then at pi over 4, we know sine and cosine are the same value, square root of 2 over 2. Well, when you divide something by itself, you get 1, right? So at pi over 4, it's going to be 1. And at negative pi over 4, that's going to be in quadrant 4, so it would be negative 1. And I'm not going to draw in the rest of the points. I'm just going to tell you that we get something that looks like this. I didn't do a very good job on that side, but it has to stay. So it kind of looks almost like has the shape of a cubic curve. And then what's going to happen, the same thing's going to happen over here. So it's going to pass through 0 at pi. At 5 pi over 4, it's going to be at 1. And at 3 pi over 4, it's going to be at negative 1. So it's going to have, again, this shape like this. And then same thing here. So we can see the shape of a tangent curve. Okay, so for tangent, the period is not 2 pi, because notice that it goes from, like, say I started at negative pi over 2 and went to pi over 2, and these are all repeats. So for tangent, the period is pi. The domain is not all real numbers. We're going to exclude, and I'm just going to say it this way, x not equal to odd multiples of pi over 2. Odd multiples because it is defined at pi, which would be a multiple of pi over 2, but the odd multiples of pi over 2. And the range is all real numbers. Okay, because you see it's going to extend down, extend up. So there you have a little overview of your trig functions, what the graphs look like.